Now, because we are writing this in C, we need to be careful of a couple of mistakes that we can make. In order to do that, this is less about, well, I suppose perfect syntax would prevent this. But this is less about syntactical error or correct inputs and outputs, and this is more about system issues. So we're writing this in C. C gives us full control. That's why almost all software that I write is either in C or assembly. We want, especially when we're doing cryptography, cyber weapons, exploits, anything where you need complete control over exactly how the operations are being done, C and assembly are fantastic options. But that gives us extra responsibilities that we need to cover. So we have some tests. We know that this is working correctly. We know that our API is going to reject bad cases, but we need to make sure that we are not doing a couple of unsafe things. So one of those is reading or writing past memory that we are allowed to. So let's say that we have this contiguous area in RAM and a caller calls in and calls from our API and says, you are going to encrypt this space. This is the allowed space. Is there coloring? This is the good space that we are, dang it, allowed to write into. This green bounded area right here. This is fine. This is where we are supposed to be operating. This is where we have permission. We do not want to read into this area or write into this area, read or write into either of these areas. So what we do for that is we're going to use something called address sanitizer to instrument memory access made by our code while our tests are executing. So normally right now we have our C code. Ooh. We have our normal build. And we're going to add an address sanitized build. So when we have this, what's going to happen is we will have our output equals our output at our offset plus I. And what this is going to make sure, so let's say that legal bound, right, ends here. Oh, I can move this up here. What this is going to make sure is that if we end up incrementing too far, like let's say we had this bound plus I, and at the end of the loop we somehow introduce another one, we would read into or write into this region right here. So address sanitizer is going to throw an error in that case and let us know that that was illegal, there was a problem, and we need to fix it. This is entirely build based. We actually won't be doing any code changes here. So we need to go into our CMake. We need to go under our CMake standard. We're going to make this an option because we don't always want to build with this. Like we wouldn't want to ship with this on. And we're just going to call this XCP enable. Usually address sanitizer is abbreviated to ASAN. And just as an information, we'll say builds with address sanitizer. And by default, this is off. So if you wanted this to be on by default, you would make this on. But we want this to be off because we want to have to enable it. And then we want to add an if statement to our build essentially. So if XCP enable ASAN is on, and then we'll just close this loop here so we don't forget to close it later. So end if So if we have enabled address sanitizer, and because we are going to want to use this with GCC and not GNU, we're going to add a check for that. So, and this might be the wrong spacing for, we'll see. If not CMake C compiler ID. So this is the name of what actually gets passed into your CMake project of the compiler name. So you might have Clang, you might have MSVC, you might have MingW. Like there's a bunch of different ones you want. So if this is not string equal to GNU, we'll want to end if this as well. So if it's not GNU, then we want to notify the user that there was a fatal error, which was that XCP enable address sanitizer requires GCC. That's just a problem I've hit my head on before, and we're using GCC to build this. So if it is GNU, we will kick out there. If not, we're going to add compile options. And those are going to be sanitize. These are flags, as if you were compiling this by hand. We're going to add flag sanitize address and flag no omit frame pointer. And then we will have to add a link option. I'm pretty sure it's plural, but it will tell me if I'm wrong. Okay, right enough. So this block is just about enabling the address sanitizer and making sure that we're using compilers that will support that. Now, there's a bunch of other compilers that will also not support it, and you can get some other compilers to support it. We can add those if we need later. We're not really looking at that right now. We just want to make sure that we're not hitting the easy oops on that. The reason that we add the link for sanitize address is that the instrumented object files are going to need the address sanitizer runtime whenever they become executable. So this will be on Linux, so it'll be an executable Linux file format, but if it was Windows, which we can build this on Windows, you can see MSVC is a compiler that we could use. Then they would be the portable executable format. So now let's build this, save this, and then we're going to build this. Now remember, we set enable address sanitization to be off by default. So when we do this, we are going to want to CMake and pass in that we want the XCP enable ASAN on. So we're just flipping that flag, that XCP enable ASAN that we set to off. We're just flipping that to be on. And then once we're done that, we are going to make. Sorry, that didn't actually show us very much. Let's do that verbosely. What is the verbose flag? Might be the debug. Perfect. Okay. That did not give us the clear sign that it built. It built, but it didn't give us the clear sign that it used the address sanitizer. So I'm going to use CMake a different way. We, instead of building into it, are going to specify a build directory. So the source, the dot means the directory that we're currently in. Dot dot would mean the recursively behind directory, the one that we're in. So this is the current directory. The build directory, we can make build asan. The generator we're using is Ninja. We can set this to debug, so dcmake build type is going to be debug, and then we have to not forget our asan flag. So xcp enable asan on. Ninja is capitalized. And then we're going to build this. So CMake, specify the build directory is build asan, and we want this to be verbose. So you can see that this built with the sanitize address on. So now we can confirm that it's linked by using the LDD or the linker. So build asan. It's going to be API test. Where is the build asan cha-cha 20? Oh. So we can see that asan was linked. So we know it was built with the address sanitizer. Now we just need to run our test. So we can run ctest. The test directory is the build asan, and we want it to output on failure. So these pass, and address sanitizer found no address issues. So I will remove the build directory so we don't try to commit it and it's not fluffing up the Git. So we'll commit this. And then next we will define our counter range contract as a bounded property, and then we're going to check that our implementation agrees with that property across the model.